close that thing and it'll keep going. Seems to be keeping going. Alright, just make sure that red light doesn't go off. If it does, just let me know. Alright everybody, so what I want to do today is two things. First of all, I want to just look at the solution to last week's lab. And well done to everyone who's in my lab. There wasn't that many people there, but it seemed everyone in my lab, almost everybody got it finished or nearly finished. So that was good. And that was the first time we've seen that in the lab for a while. So I don't know, the games thing seems to be working a little bit. And then the second thing I want to talk about is how to rotate things and how to scale things in XNA. Alright? So I'm not going to move forward the OO bit anymore, but I'll basically show you, I suppose, other applications of calling methods on instances of classes and statics and things like that. So we were working last week on an abstract class, isn't that right? And this is actually the full solution for everything in MISTIbat. So there's going to be loads of stuff in here which we'll do over the coming weeks. But the first thing we said was that we had to make an abstract class called GameEntity. So this is how you make an abstract class. You just put the word abstract in front of the class, and that makes the class an abstract class. And then I added 3 methods to the abstract class: load content, update, and draw. Now just looking at this example here, there's a couple of things we can learn that are sort of the rules of when you're making an abstract class. Number one thing, when you make an abstract class, what can we say about an abstract class? When you make an abstract class, number one, what's that? You can't make an instance of an abstract class. That's the number one rule. Number two rule of an abstract class is this thing here. What's this rule about? Looking at these methods, what's the significance of them versus this method here? These methods are abstract, right? So they got the word abstract in there. What's the difference between these methods and this method?
They have to be used.
What's that? Yeah, they have to be. If you want to make a subclass of this, you have to make methods which implement these methods here. But what's the significance of these ones in the base class, in the abstract class?
You don't put anything into it.
No body, exactly. So look at that. There's just a signature for the method with a semicolon in. There's no open and closed curly brackets here. So there's rule number 2 of an abstract class. Rule number 1 is that you can no longer instantiate it because it's abstract. Rule number 2 is the methods in the abstract class don't have to have a body. And then related to this idea is if you make a subclass of this class, you have to include an implementation of load content, update, and draw. So when you make something an abstract class, and you use abstract classes in your project, this is a way of guaranteeing that classes implement certain methods. So it's anything that extends GameEntity, I know it's going to have a load content method, I know it's going to have an update method, and I know it's going to have a draw method. So there's the 3 rules of an abstract class. You can put other methods in here which are not abstract, and of course the abstract class can have velocity and sprite and other variables in there, other fields, and it can have other properties. Is that alright with everybody? Anybody want to ask any questions about the abstract class?
So is that like setting up a framework for everything that it extends?
Exactly.
Extends
from now on, all the stuff that we make, and in your assignment as well, is going to extend a class like this.
That's your frame.
And that's us guaranteeing that everything loads content, updates, and draws. Is that alright? So that's the first thing. The second thing then, you notice that I put velocity and I put, the position, velocity, and the sprite in there. But the back class then, alright, the back class, this colon thing, what does that indicate? When you go back colon GameEntity, what does that indicate?
It's a
It's a subclass, right? So everything GameEntity has, BAT also has. So I add some extra things in here, but notice that GameEntity has a field called position. Yep, so GameEntity has got a field called position, so that means the BAT also has a position. And down here in the update method, you know, I can basically affect the position and the velocity because it gets those from the base class, alright? So they come from GameEntity, they're not declared in here. And then down here in draw, I can also make use of the sprite. And you notice that it's not declared in this class, it gets it from the base class, gets it from the GameEntity class. Alright, so sprite and position come from the base class. So the other thing then I wanted you to make use of was the idea of a static, right? So if you look at game 1, the problem now is that there are certain things that all of our game entities need access to. So all our game entities need to load their content from the content, and all our game entities need to draw using the sprite batch. These things are owned by the game1 instance. So how I get around this is by making a static here. So I go public static game1 instance. What does the static indicate here?
That you don't need to put something into it.
It means
I can't think of it.
in a single sentence you're getting it right, but just in terms of the exam now, right? I will ask a question like define, certain terms, right? And if you don't get the definition the way I expect it to be written, you don't get the marks, right? So you must write it in this way, and this is something you need to write down, or find a definition on Wikipedia or something, whatever works for you, if it makes sense, right? But I know what you're getting at, but you have to have the right terminology. What this means is that instance applies to the class, this variable called instance applies to the class game1 rather than an instance of game1. So it applies to all games that I create, which are instances of this class, is another way of saying it, but basically it also means that you don't have to have an instance of the class created to make use of a static. And we'll make use of other statics in other classes as well today, right? So you can see how XNA framework makes use of statics. But this is us making use of a static. Basically saying that this variable does not require an instance to be created to make use of it. So I call it instance because it refers to, in programming, a thing called a singleton, and statics are used to implement what are called singletons. A class basically that there's only ever one instance of. And this is how you do it. And this game1 here, this is what's this method? It's the constructor. No return type. See, that's just public game1, and it's the same name as the class. So that's the constructor. And in here, I just go instance equals this. What does this indicate?
Current.
The current object. So when this current object gets created, it assigns this instance to be the object that's just created. And that's how you make use of the static. Is that alright? So once that's done, in something like the bat class, you can just go game1.instance. Like this, game1.instance.spriteBat. And you notice that I'm doing game1, not an instance of it. Game1 here is the class game1.instance. And that's the static. So that's how I make use of the static, right? And then if we, is there anything else significant here? Yeah, in the update, here's an example of static methods, right? You can see here that in the update method, I go keyboard state, key state equals keyboard.getState. This is an example of a static method, because the class is called keyboard. Right? There's no instance of the keyboard created. There's no keyboard equals new keyboard, which is how you instantiate things. So just keyboard.getState, and that's calling a static method of the keyboard. And the other thing then, you can see to construct the sprite, this is how sprites get loaded from a file. You use game1.instance, the static, and then content, which is a reference to the content pipeline, .load, and then the texture, and that's how you load it. Everyone got this loaded. I don't know why I'm spending so much time on this. Does anyone want to ask any questions about this? Or about the lab last week? Before we move on a little bit. Yeah?
I just had a question around the velocity.
Yeah.
Use that in the back class.
Yeah, so we might get to that if that's alright. How did I use it? Well, I'll tell you what, we've a little bit more to do before we get to using velocity, right? We'll talk today about how to make things rotate. How I used it was, we say when you, for the ball or for the bat? For the bat, what I do is, I think I just set the velocity, and then I use the equations of motion, just a little bit of Newtonian physics, which is basically position equals position plus the velocity multiplied with the time delta. And then something simple like that, a little bit of that equation to move the things around, to move the ball around. But before we do that, let's talk about how to rotate things today, okay? So, that's that. I'm going to open up this other little program, which is the rotating sprite, the rotating tank sprite that we were working on. Get rid of all of this code here, which I was working on earlier. Now, okay, so we were working on the rotating tank last week, weren't we? And we learned that we can rotate things by passing in an additional parameter to the draw method, and that parameter is the amount by which you want it to rotate. So here we go, this is sprite, position, null, color.white, rot, which is the variable. And this is kind of where we finished off last week. We had a tank that could move up and down like this, and we could rotate it left and right like this. But when we moved, we weren't moving in the direction in which we were pointing. So we want to make use of a little bit of trigonometry to try and figure that one out. So let's bring the screen up. Is that okay with everybody? That's where we were last week, yeah? And that lecture's on YouTube if anyone wants to watch it, right? You missed it for any reason. No. Alright. Here we go. Today's lecture starts with this. Alright. What's that? Huh?
Circle radians.
What is it? Everybody say it? Very good. Great. That's the first thing. That's a circle. Has everyone seen one of these before? Okay, that's a circle. Alright. In our little game, our sprite, if we don't rotate it at all, you know, just the way it's drawn in Paint, it's drawn with the tank pointing straight upwards. If you just load it up into Paint or into GIMP or something like that, it's pointing straight upwards, right? So this doesn't mean I'm not rotating the sprite. When I start rotating the sprite, you can specify the rotation in degrees, okay? You can basically say, if it's pointing straight up, it's 0 degrees rotation. So no rotation applied, that means I'm not rotating it at all. That's fair enough, it's pointing straight up like that. If I was to rotate it by 90 degrees, it would end up pointing in this direction here, isn't it? And we discovered last week that these rotations in X and A, are they clockwise or anti-clockwise?
Clockwise.
They're clockwise, alright? So that means the rotations move in this direction here. If you rotate it by minus 90 degrees, then that means it would go in the opposite direction. Is that okay? And this only happens when you call the draw method, right? So, when you call the draw method, you pass in a parameter saying, well, how would you want the thing to rotate when it gets drawn? So that's a 90 degree rotation. All the way down here, this is a 180 degree rotation. I'll draw these in here, this is 90. And then all the way around here, this is 270 degrees. And then all the way over to here is 360 degrees. So we said a rotation of 360 degrees is the same as a rotation of 0. Isn't that fair enough? When you rotate by 360 degrees, you might as well not bother rotating at all, because it's just the same as a 0 rotation. So then we were looking at, you know, how computers represent orientations and rotations, and they represent them using radians. So we said that if that's the radius of the circle there, we can say that the radius of this particular circle is equals to 1. We'll just pick that number. It doesn't really matter. 1 is a nice handy number. If the radius of that was equals to 1, the whole circumference, if you start walking all the way around to here, roughly how many units would you walk? Yeah, 2 pi. So you walk around roughly in numbers. What's that? What's pi? So pi is roughly 3.14. Pi is 3.14159, and it goes on forever. If you start walking around here, eventually you will have walked 6.28 units. Alright, so if that was a meter, you'd have walked around 6.28 meters. And that's the radius of the circle, okay? So, that's what a radian is. It's a unit of the radius of the circle. So if you were to walk this 90 degree thing, how far would you have walked? You would have walked pi over 2 radians. And if you walked this far, you would have walked pi radians. And then this is 3 pi over 2, or 1.5 pi, right? And then you walk all the way around here, and you'll have gone 2 pi radians. And that's what radians are. Is that okay with everybody? So that's kind of where we left it last week. And we can rotate the thing. We do have a bit of a problem now, okay? And the problem is that we want our tank to drive in the direction in which it's pointing. Is that fair enough? So, let's try and write in some numbers for which directions we want it to go. If I don't apply any rotation, what do I add to the x to get it to move? And what do I add to the y? If I don't rotate it at all. What do I add to the x every update? Huh? You don't add anything to the x. Alright, so if I wanted to move straight up, I do nothing to the x. And what do I do to the y? I subtract from the y, okay? So 0 and minus 1 is a vector which describes, if I don't apply any rotation, that's the direction in which I want it to move. By this I mean I add nothing to the x and I subtract from the y. Is that fair enough? Everyone happy with that? If I subtract from the y, it will move upwards because my origin's in the top here. Next thing then, if I wanted to move in this direction, what do I add to the x? Do I add anything to the x to get it to move in that direction? So adding to the x, and what do I do to the y? Nothing to the y. And then down here, what do I do? Nothing to the x, add to the y. Over here, minus the x and nothing to the y. So that's how I get it to move in that particular area. I'll turn this off. Is that alright so far? Problem, okay? I'm not always going in those four directions. Sometimes I want to move in this direction here. And if I want to move in that direction, then there's something I have to add something to the x and subtract something from the y. Isn't that right? So I'm going to do something to both of them. So we need to calculate. This, by the way, this type of circle here is a special circle. Anybody know what it's called? Because it has a radius of 1, it's got a special name. So you know what it is? Yeah, it's called a unit circle. Great. It's called a unit circle. A unit circle is just a circle with a radius of 1. It's actually, I think, a unit circle, a radius of 1. By the way, if that's 0 and minus 1, that's 0, 1, that's 1, 0, that's minus 1, 0. What's the coordinates of the center of that circle? 0, 0. Great. So everybody, is this all really easy so far? Cool. Alright. The next thing we gotta learn about is this. So we're moving on a little bit. And now we have a new shape. What do we call that one? Square? Who said square? It's called a triangle. It's called a triangle because there are 3 angles. Well done. Okay, this is a special triangle because that angle in there is 90 degrees. Alright? That's a 90-degree angle there, isn't it? Let's pick one of the other angles. Let's pick this angle here, and I call this angle theta. No particular reason, that's just typically when you're drawing diagrams with angles in it, you always call the angle theta. We could equally have called that one theta, it wouldn't make any difference. Even that one could be theta, but we know this one. This is just an angle in a triangle. Now, if we take that triangle, and let's name the sides. Okay, I'm going to call this side here O, I'm going to call this side H, and I'm going to call this side A. Alrighty? Let's say a couple of things about this. Let's imagine I split the sides of this triangle and I divided that one in 2. So now I have 2 triangles. One big triangle, one small triangle. And so I'm going to call this one A prime, H prime, and O prime. Okay? No particular reason, just naming them. We can say that the ratios between the lengths of those sides are the same, regardless of what the overall lengths are. Because the angle doesn't change. So what you can say is that O over H is also equals to O prime over H prime. Isn't that fair enough? Does everybody agree? Following what I'm doing so far? You can also take those other ones. You can say that A over H is the same as that A over that H. Yeah? And you can also say that O over A is the same as O prime over A prime. Happy? These ratios have got names, don't they? And they are the same for every triangle that has a right angle for it, that has the same theta. The first ratio is called, if we pick our first ratio, the O over H. That's called the sine of the angle, right? Equals the sine ratio. That's what it's called. So when you look up the sine of 45 degrees or the sine of 80 degrees, that's what you're actually calculating. The ratio of the lengths of the opposite over the hypotenuse. The other ratio you have is called a cosine ratio. Cos of that is equals to that, adjacent over hypotenuse. Everybody should be taking notes here, by the way. I presume you all are. And then the final ratio we have is called the opposite over the adjacent. And that is called the tangent ratio. Now, how many people have seen these before? How many people haven't seen these before? How many people? Okay, right? Okay. So there are those ratios. All right, there are related ratios to this, but anyway, we'll do that in a minute. Now, let's see if we can use these ratios in this problem over here. Let me call that theta. So I'm rotating by theta radians like this. Okay? And then I want to draw a line across here to make a right angle triangle out of it. So if that's theta in there, then this one here is going to be opposite. This one here is the hypotenuse, and this one here is the adjacent. Isn't that right? Following? So then the next thing is we basically say, what is it we're looking for? I'm looking for x comma y. I'm looking for those coordinates on that circle there. By the way, what's h in this diagram? H is 1. It's 1. Because the radius of that circle is 1, so h is 1. So they're always over 1.